So when you have to get scalar quantities, you use dot product. When you have to get the vector quantities, you use cross product. We'll tell you this. Now see, here remember one thing, that units will remain the same. As in, if I have, this was one point which I couldn't tell you last time. If I have this and I have n times this vector, so this becomes 3 times 2 I cap Newton, right? So at the end, I'll be having 6 I cap Newton, means the units will remain the same in this case. Fine. Here also, see, if I have to calculate force, force is mass into acceleration. So what is mass? 2 kg. Acceleration is 2 I cap meter per second square. So when you multiply, this becomes 4 kg meter per second square I cap. Though this is called Newton also, we already know this unit, this is Newton. But we'll be writing it here this manner just to show you that the units are same. Otherwise, the unit of force is Newton only. That is 1 kilometer, 1 kg per second. This 1 kg meter per second square. This is the unit of acceleration force, equal to 1 Newton. All right, now I'll start with dot product first. With okay, just do one thing. Write down this part that was left from that table. Then I'll start with your dot product. And this will be used. This is also like the, see, vector quantities are not just a separate topic for you to understand. These are quantities which will help you solve your answers also in the exam. Not for this chapter, for all the chapters which are present. In class 12th also you will be utilizing it. Anyways, write it down. Done? Other students also, please open the cameras. It's only Jobita who has followed the instructions by herself. Other students also, this instruction is not just for her. This is for all of you. All right, it is just because we do not have this offline class, we are having online class. So at least with this platform, let us make it more interactive. This is valid for Sabiha also and Zainab also. Okay, I'll start with dot product now. See, what is dot product? Basically, we call it as the scalar product. So scalar product means when you multiply these two vector quantities, the final result will be a scalar. Like if I give you an example, force is a vector quantity, right? Displacement is a vector quantity. But when you multiply force and displacement using dot product, F dot D, this gives you work done. And work done is a scalar quantity. This is scalar, this is vector, this is vector. So you will be having vector quantities. When you multiply them, you will finally get a scalar quantity. In this case, we use a dot product. Now the solving part of dot product, it's not difficult. You will be able to understand it. See how. These are the two vectors which are present. They are subtending certain angle between them. Now parallelogram law is there to find out the resultant. But if you have to find out the product, you have to multiply these two. Then you cannot use the parallelogram law because you don't need the resultant, right? So what we will do here, when it is A dot B, means when you are using the dot product, A dot B, take the magnitude of A, take the magnitude of B, and multiply it with this cos theta. So magnitude of A, magnitude of B multiplied to cos theta. So when you're writing A dot B, this is equal to AB cos theta. For example, I'll give you this example. This is V1 vector dot V2 vector. Both of these are vectors. So take the magnitude of the first vector. This is -3. So I have to take the magnitude. That will become 3. Multiplied to second vector's magnitude. This is +5. It will be 5. Into cos 60 degree. That's it. Fine. So this becomes 15. This becomes half. So you have simply 7.5 meter per second. Fine. So V1 dot V2, when you will write, you will take the magnitude of each of these quantities. Properties, I'll tell you first, write down this basic one. Now, see, next, when we are talking about the properties of a dot product, one is very clear that the resultant is scalar. And see, it is commutative, means if I was giving you this example no, between this force and this velocity. So if you have force multiplied to velocity or you multiply force with velocity, it's the same. Like we have in our normal multiplication, 3 into 2. If I say 3 multiplied to 2, that will also give me 6. Or if I say 2 multiplied to 3, that will also give me 6. So it is commutative. This is valid for dot product. Fine. Now, perpendicular vectors mean, see, I cap, j cap, k cap, all these are the unit vectors of the Cartesian plane, right? And I cap represents x-axis, j cap represents y-axis, and k cap represents z-axis. Now, all these axes are perpendicular to each other. So, if these vectors are multiplied, these perpendicular unit vectors are multiplied, you get 0. Why am I emphasizing on this? Because you will be having questions where Cartesian form will also be given. So you should know which quantities are 0, 0 on multiplying. So I dot j, j dot k, j dot I, k dot j, all these are completely 0. But what about the parallel vectors? Parallel means, see, is I cap parallel to x axis? Yes, I cap is on the x axis only. So obviously it will be parallel to it. It means I cap dot I cap. If you multiply the same vectors with it, means if I have I cap dot I cap, j cap dot j cap, k cap dot k cap. In this case, what happens? Theta becomes 0 degree. So cos theta becomes cos 0 degree becomes 1. So final answer becomes 1. And unit vectors, you already know the magnitude is 1. So it's 1 into cos 0 degree is also 1. So finally the answer is 1. But when we are talking about the perpendicular vectors, here the angle cos theta, this becomes 0. Why? Because our theta here is 90 degrees. All these axes are perpendicular to each other. X, Y, and Z, all these are perpendicular to each other. So that's why this angle becomes 90 degree. So when you multiply these it amongst them, like I cap from here, j cap from here, k cap, or the negative ones, you directly get 0 because theta is 0 here. And unit vectors always have the magnitude as 1. So magnitude 1, second vector magnitude 1, and then the angle is 0. So final answer 0. That's why you have lines of zeros over here, and you just have 1 over here. Please remember it because you'll be getting questions where you have I cap and all these getting multiplied. Last property. See, when two vectors are parallel, and suppose I have this a dot a, and a cos 0 degree is present, it means a into a. So I can easily write it as a square. Means you don't have to leave your answer at this step, you have to multiply it. All right, so when you have the like vectors, a dot a means the exact same vectors are present. So it just becomes square of the first. Fine. A dot a, f dot f, s dot s, if the two vectors are identical. This is a case for identical vectors. So this was the introductory part of the dot product. Fine. This I have told you f dot s, this is giving you force, this is displacement, giving you work done. Vector into vector, giving you scalar. Here also power is equal to f dot v. So force dot velocity is equal to power. Power is scalar, so vector into vector is scalar. Fine. This is for this. Theta is 0 and cos t. In Cartesian form, now your proper calculations part will start. First, write down these properties. C class. Now how do you have to solve the dot product? When you have the two Cartesian forms present, like this, two vectors are present written in the Cartesian form. What we do, we multiply the same coefficients. Like we'll be multiplying the coefficients of I cap together. See, A1 from here gets multiplied to B1. And what is, so this becomes A1 into B1. And what is I cap dot I cap? That's 1. So we won't write it. That's 1 already. Come to this. Then again, A2 multiplied to this B2. And J cap dot J cap is 1 only. Similarly, here also A3 multiplied to B3. So this is what we have. Now look at the actual example. So here we have 3. Here we have 1. Right? So A dot B. That was in polar form. A, B, cos theta was in polar form. Polar form means when the angle is present. This is the Cartesian form. Cartesian form means when I cap, J cap, K cap, these are mentioned. So polar form was clear. A, B, cos theta. Here in Cartesian form, you multiply the coefficients 3 into 1. Then I cap dot I cap is 1, so we won't write anything else. This becomes plus, this becomes minus 3 into minus 1. Fine, minus 3 from here and minus 1 from here. Plus, this is 4, or let me write it together. This is 3. This is 3 into 1. This is 4 into 1. So this becomes 4 into minus 1. So you have your answer as this is 3. This becomes 3. This becomes minus 4. So you have 6 minus 4, which is 2. That's your answer. This is how you have to solve the questions of dot product. Multiply the like coefficients together. This question I'll discuss. First, write down this. And any doubts if you have, please get it clarified. Now, look, class, this question says, this force is given and it displaces the body from A point to B point. Let us write this whenever you have coordinates given and you know that you require the Cartesian form. So convert it in Cartesian form already by yourself. Like this is X, this is Y, this is Z. So this becomes 2I cap plus 3J cap plus 0K cap means nothing. And what about RB? This becomes 4I cap plus 2J cap plus K cap. Now, here, since we have not done this chapter, work done and force and displacement, I have already told you right now, we'll be doing it. Anyways, we'll be doing it in chapter 5th. It is F dot R. That is force into displacement. So if the initial point is given to us, final point is given to us, first let us calculate the displacement. How do you calculate the displacement? You have the final point as RB, initial point as RA. So when you subtract these, 4I cap minus 2I cap, that becomes 2I cap. 2J cap minus 3J cap, that becomes minus J cap. K cap minus 0 plus K cap. This is the radius vector. And what is this? 2 plus 3 minus. Okay, Zainab has calculated. And the force is 2I cap plus 3J cap minus 5K cap. So if I have this as my radius vector, now I want to find out work done. So 2 multiplied to 2 plus this becomes 3 multiplied to minus 1. Okay, Zainab, second answer is your answer. Let us see. And this is minus 5 into 1. 4 minus 3, right? Minus 5. 4 minus 8, minus 4. How come 10? This is 4, this is minus 3, this is minus 5. 4 minus 3 minus 5. Write it. See here, the polar form will be used. This question, calculate the angle between A and B. See here, class. In this question, we have to find out angle. So it means you have to use the polar form. Now, how can we use the Cartesian form and polar form together? So see, we know that A dot B, this is equal to magnitude of A multiplied to magnitude of B multiplied to cos theta. Now we have to get cos theta from here. So we require this. We require this. Let us find out A dot B first. We can find out using this. So 1 gets multiplied to this 1. So 1 into 1 plus This 2 gets multiplied to this minus 2. So 2 into minus 2. Plus this 3 multiplied to minus 5. So this becomes 1 minus 4 minus 15. Right? So this is minus 3. Minus 3 minus 15. This is minus 18. This is A dot B. Now, secondly, you require, stop writing everyone. You require magnitude of vector A. How do you calculate the magnitude of vector A? Yes, Zainab. Tell me the magnitude of this vector A, and Shaima, you tell me the vector of this, magnitude of this vector B. Okay, Zainab has calculated. Yes, Shaima, vector B. See, 1 square under root a coefficient of I square plus coefficient of j square plus coefficient of k cap square. So 1 square plus 2 square plus 3 square under root. So this will be magnitude of vector A will be calculated as under root 1 square. What was it? 2 and 3. 2 and 3. Yes. So this is 2 square and coefficient of k cap 3 square. So this becomes 1 plus 4 plus 9. So yes, Zainab has given the correct answer. This is root 14. What about you, Shaima? Still not answered. Vector B, how do we calculate the magnitude? Same thing, under root coefficient of I square, j square and k cap. So 1 minus 2. This is 1 square minus 2 whole square plus minus 5 whole square. 1 minus 2 minus 5. So this will be 1 minus 4. No, this will be plus 4. And this is 25. So this is root 30, correct. Yes, yes, root 30, very good. Now we have cos theta equal to A dot B divided by the magnitude of the vector A and the vector B. So cos theta would be equal to 18 divided by root 14 into root 30. All right. So you'll multiply root 14 with root 30. So this will be 420, right? So this is 18 by 420. You can further solve it and theta will be inverse of this. So this is how you can relate both of these. Write down. Yes, yes, it will be reduced. Yes, Zainab, you will have to reduce it. Done? All of you have completed?
Yes, ma'am.
Fine. Now, one more thing. See, sometimes a question is given. This comes only from this chapter, particularly, not from the general case, where component of A along B is asked. means vector A, the component of vector A along B is asked, or sometimes instead of this component word, projection word is used. Projection of A on B, projection of B on A in this manner. So see, vector is A vector. Now this is the formula which you have to remember. Vector A gets multiplied with the, or not multiplied actually, there's a dot product of B cap with vector A taken. B cap is what? You know how to construct a unit vector, right? So unit vector will be constructed first, and then that will be multiplied to the normal vector, which will further be multiplied to the unit vector. Like take the vector A, calculate the unit vector of B, make the unit vector of B. How to make the unit vector of any quantity? Take the vector, divide it by its magnitude. So you get the vector A and vector B. So this multiplied to the as it is vector, multiplied to this term again. That's how you have to solve it, and that's how you have to calculate it. Write it first. Write down this note point, then I'll teach you this with the help of an example. See, in this question, you have vector A with the vector B. You have to calculate the component of A along B. Now what we are going to do, we have to find out A along B and B along A we have. So let us calculate one second. You can calculate on your own. A multiplied to the unit vector of B cap multiplied to B cap. Let us find out what is the unit vector of B cap. Take the vector as it is and divide by its magnitude. What is the vector? I cap minus j cap minus k cap. Its magnitude will definitely be root 3. And what is the vector A? I cap plus j cap minus 2k cap. This is the vector A. It is I cap plus 2j cap plus 2k cap. Now what we'll do, we'll multiply this entire term with this, right? So this is I cap's coefficient. You can write it in this way also. I cap by root 3 minus j cap by root 3 minus k cap by root 3. So 1 by root 3 getting multiplied to 1. You will get 1 by root 3 plus minus 1 by root 3 getting multiplied to plus j cap. That becomes minus. Root 6. 1 plus 1 plus 1. Root 3 how 6? Okay, this is 2 cap. No, but we are calculating it for the B vector. You're asking for this. Are you saying that this is 4 plus 1 plus 1? We are calculating B cap. So that's why I had taken I cap minus j cap minus k cap. Now this is vector A. Now we are multiplying these two. So 1 by root 3 into 1 is 1 by root 3. 1 into minus 1 by root 3 is minus 1 by root 3. Right? And minus 2 getting multiplied to this, that becomes plus 2 by root 3. So this becomes 1 minus 1 will be 0. Final answer would be 2 by root 3. So this is just, what is this? This is A vector dot multiplied to B cap. This is this part which I have written. But what about this? We have to multiply it to B cap also. So 2, finally we'll have A vector multiplied to B cap multiplied to B cap. What is this bracket? This bracket is 2 by root 3. Multiply to, what is the B unit vector? I cap minus j cap. I cap minus j cap minus k cap into divided by root 3. This is the unit vector. Now this is our final answer. So let us multiply these two terms. So this will become 2 I cap by 3 minus 2 j cap by 3 minus 2 k cap by. Why 3? Because root 3 into root 3. Similarly, you have to calculate in the second part when you have to calculate B vector along it. So here you will have A cap and here you will have B vector. It will be reversed. Write it down. Okay, now one more thing, class. When you have the geometrical meaning of a dot product, sometimes you will get geometrical meaning of a dot product. In that case, you multiply the same thing what you have studied, p vector dot a cap multiplied to this a cap, same thing you study. Now, after this, there's sometimes it is asked, what is the geometrical meaning of a dot product? Rarely this question is asked though. So geometrical meaning of a dot product means this is vector A, this is vector B. Angle between them is cos theta. So projection of A on B actually is A cos theta. See class, you know that this angle is theta, which is if the theta is made with a certain axis, we say cos component is given to it, right? Cos theta, we say the cos component is given to it. That's why this is A cos theta. So when you have the geometrical meaning of a dot product, geometrical meaning of a dot product means A vector component on B, that is A cos theta. If the theta was made here, then it would have been B cos theta, like this. So vector A. So this is what we say, projection of A on B, component of A on B, like this. So that's your dot product all about. Write down this portion also, class. And yes, same line here as well, that dot product of two vectors is the product of magnitude of one vector and projection of another.